Welcome back to All This Math. This is Professor Parker. And for this lesson, we're going to do some more work with completing the square, or completing the perfect square trinomial, because we start out with a binomial and then we got to complete it and change it into a trinomial, and then we factor it and keep going and do some other steps in order to solve for x and get x all by itself. All right, so look, we start out with x squared minus 6x equals negative 91. So you see, this is not in standard form. The problem is already given to us basically with the first step already done. This constant term is on the right-hand side by itself. So it don't start out like this, right? ax squared plus bx plus c equals 0, right? So we got x squared minus 6x is equal to negative 91, right? So this is our incomplete perfect square trinomial. It's incomplete. We got to make it complete. So the way we make it complete is by using this formula, b over 2 to the second power. So write that down on your paper. b over 2 to the second power. All right, now you might be wondering, what is b? Where do we get b from? B, that's a good question. That's a good thing to be wondering about. B is the coefficient of the x term, or your linear term. Now, what's a coefficient? A coefficient is a number. It could be a fraction, could be a whole number, could be a decimal, right? That is adjacent to a variable, right? And it tells you how many of that variable you have. In this case, b is negative 6, because this says negative 6x or minus 6x. So my b is negative 6, not positive 6. It's the actual number. The actual number is negative 6. So b is negative 6. So I'm going to replace b with negative 6, and then I'm going to do the math. So negative 6 over 2 squared. Negative 6 over 2 is negative 3. Negative 3 squared is equal to positive 9. Because a negative times a negative is a positive. So this number is going to complete my perfect square trinomial. That's what that number does. That's what 9 does. All right, so now I got x squared minus 6x plus 9. And because this is an equation, I can't just add 9 on the left-hand side and not add 9 on the right. I can't do that. That's not cool. We got to keep everything balanced. We got to stay balanced. So we got negative 91 on the right. So if I add 9 on the left side, I got to add 9 on the right side, right? So now, the purpose of creating a perfect square trinomial is because I know that I can factor a perfect square trinomial a certain way. I know I can do that. So because it's a perfect square trinomial, the trick to factoring those is you just write a binomial, right? Binomial meaning it's going to have two terms in it. So I do my parentheses. I put my exponent 2 outside. I take the square root of the first term. The square root of x squared is just x, right? So I put x right here. Then I take the square root of the last term. The last term is 9. The square root of 9 is 3, because 3 times 3 is 9. So I put a 3 right here. And then I put a minus sign in between. Now, why do I do that as opposed to a plus sign? Because my middle term was negative. It defaults to the sign of the middle term from that trinomial. If this was negative, that means you put a minus sign here. If this was positive, you put a positive plus sign here. But this was negative, so you throw the minus sign right there. So that's the factor form of that, right? We got x minus 3 to the second power. That's the factor form of that. Then on the right-hand side, we got negative 91 plus 9. Negative 91 plus 9, do a little mental math. That's the same thing as doing 91 minus 9, but then making your answer negative. What's 91 take away 9? So I would say 91 take away 9, that's like 11 minus 9 would be 2. So 91 take away 9 would be 82, right? But my answer needs to be negative because 91 was negative. So I got negative 82, right? So this is the quantity x minus 3 to the second power is equal to negative 82, all right? Now, I'm trying to get x by itself, so it's two things I got to do. I got to get rid of this exponent 2, and I got to get rid of this negative 3. Those are my last two things I got to do, because when you solve for x, you basically just trying to get x by itself on one side of the equal sign. So if you think about it like that, like, all right, like what do I have to get rid of, and how do I get rid of those things mathematically using mathematical rules, right? Because you can't just sit up here and just cross the 2 out and cross the 3 out and be like, all right, I'm done. Nah, you can't do that. We got to follow rules. We got to be disciplined and follow rules. We got to follow protocol, right? Because when people start, cease to follow protocol and, just start doing things all willy-nilly, that's when like everything goes crazy, right? So the way we get rid of this exponent is by doing the opposite or the inverse operation. We take the square root. So it looks like this. The square root of the quantity x minus 3 to the second power is equal to, now, because I took the square root on the left-hand side, I got to take the square root on the right-hand side. Whatever I do on the left, I got to do on the right. I got to keep it balanced. You got to keep it balanced, keep it fair, right? Think about fairness, equality, equity, all that. Balance. So it's going to look like this, the square root of negative 82. Now, something weird going to happen that I'm going to talk about, because this is a negative radicand, the number under the radical sign, we call that a radicand, all right? Now, also something I forgot to write. When we take the square root of something on both sides of an equation, you must put a plus or minus sign, because you must indicate that the positive value of this is relevant and also the negative value of this is relevant as well, right? So now once we actually apply the square root, that's going to leave us with just x minus 3 equals plus or minus the square root of negative 82. All right, so now I'm trying to get x by itself, so I got to get rid of this negative 3, right? I got to get rid of this negative 3. So the way I get rid of this negative 3 is, excuse me, the way I get rid of this negative 3 is I could either do plus 3 on the left and then plus 3 over here. I could think of it like that. Or what I like to do is transpose. I like to transpose. I like to basically just pick up this negative 3 and just slide it to the other side of the equal sign. Just keep it, nice and neat. Just slide it over, right? But when I slide it over, the sign has to change. The sign has to change. So it was a negative 3 or a minus 3. It's going to become a positive 3. So it's going to look like this. X equals positive 3 plus or minus the square root of negative 82. Right? Now, we could be done, but in terms of simplification, we got to do something with this square root of negative 82. So I don't know if your teachers have introduced or your professors introduced you to the concept of imaginary numbers, but that's what we're working with here. We're working with an imaginary number. Whenever you have the square root of a negative number, that has an imaginary part to it. Because think about it. We're dealing with the real number system, right? It's no way in real life you can take the square root of a negative number based on the rules of multiplication of negative numbers. Because dig it, right? When you take the square root of a number, that means you find that you're finding a number that can be multiplied by itself to equal that number. Case in point, let's say I want the square root of 9. The square root of 9 is either 3 or negative 3, because 3 times itself, 3 times 3 equals positive 9. Likewise, negative 3 times negative 3 also equals positive 9, right? How is it that any number can be multiplied by itself and you end up with a negative number result? That's impossible in the real number system. When we keep it real with numbers and we're dealing with the real number system, that can't happen. Because the only way you end up with a negative number product is when you got a negative and a positive. And if you multiply a number by the same exact number, how can one number be negative and one number be positive? It's impossible. So therefore, in the real number system, that can't happen. But we have a way to account for that called imaginary numbers. So basically the way you do it is you basically break this down, right? And 82 is not a perfect square, so we just leave the 82. But you want to separate negative 82 into negative 1 and 82, because that's equivalent to negative 1 times 82. And we use the lowercase letter I, which stands for the word imaginary, to represent the square root of a negative 1. That's what we use that for. We use the lowercase letter I, right? So letter I equals imaginary. All right, lowercase letter I, imaginary. It's not real, right? It's imaginary. It's make-believe. It's made up. It's fake. All right. Let me see. It's made up, right? Imaginary. Like the concept of white supremacy. It's imaginary. It's made up, right? I mean, it manifests itself in very tangible and real ways, but as far as an actual ideology, it does not really exist. It's imaginary. It's just that certain people have had the ability over time to impress it upon us and have many of us to buy into it as if it was real, but it's in fact imaginary. It's imaginary. It's a long-term project started about 500 or 600 years ago, right, on Earth, but it's imaginary, right? Like the square root of negative 1 is imaginary in the real number system. So let's do this, right? So as we got x equals 3 plus or minus the square root of negative 1 times 82. Now the square root of negative 1, I told you, that's going to come out and become lowercase letter I, right? So we end up with x equals 3 plus or minus I times the square root of 82. 82 can't come out. It's not a perfect square. So 82 don't come out. It's not a perfect square. And then we think about it, can we break 82 down? The factors of 82, 2 times 41. 82 don't have a lot of factors. 2 times 41. Yeah, it's not divisible by 4. It's divisible by 6. No, I don't think it's not divisible by 6. Yeah, 82 does not have a lot of factors. So we can leave it as this. So this will be our final answer. X is equal to 3 plus or minus I times the square root of 82, right? So our two answers are actually 3 plus I times the square root of 82, as well as 3 minus I times the square root of 82. But this is not a real number anyway, right? So this is not a real number solution anyway. This will be in the complex number realm, right? That we can get into at another time, more deeply in another video. But right here, this is our solution. Boom. X equals 3 plus or minus I times the square root of 82. All right. So go forth. I've shown you how to do it. Use this video as a reference. Go forth and practice. Do some more videos on your own time so that you can become proficient and master this skill of completing the square to solve quadratic equations. All right. So go get some practice and I'll catch up with you on the next video. Peace.